In this interview, we talk about how Reddit handles over 160 million uniques a month and billions of page views. How do you track errors in development, and how do you know when your users run into errors? Do you even have an error tracking strategy? Mine was terrible, but I found a solution that I really like. Rollbar is an incredible product, and I'm not just saying that because they're sponsoring the show. I'm actually using Rollbar at Scale Your Code. I'll tell you more about that later in this episode, but go to try.rollbar.com/SYC and set it up with your app. It's really easy. It took me 5 minutes, and it works with any language and any tool you need. try.rollbar.com/SYC. Hey fellow coders, my name is Christoph. I'm the host of Scale Your Code, where ambitious and successful developers teach us how they do it. Today's interview is going to be really interesting because we have two giants with different technical difficulties. And today's guest, Jeremy Edberg, is going to explain to us how he overcame these difficulties and scaled these sites to incredible heights. Jeremy was the first paid employee and chief architect at Reddit, and the reliability architect at Netflix. He's also created his own company called Cloud Native. We're going to be talking about all three of these in chronological order so we can more easily compare and contrast them. Jeremy, welcome to the show.
Thank you. Good to be here.
So tell us about the story of how you got started with Reddit. How did you become the employee number one?
So that's a pretty funny story, actually. I went to demo day, or not demo day, startup school in Boston, the very first startup school for Y Combinator. And I ended up meeting the Reddit guys there, which was intentional because I had actually had sort of a similar idea. And then when I Googled around, I found Reddit. And so I had joined Reddit. And so I'd been on Reddit for a couple months. I flew out to Boston and I got invited to this like pre-party thing. And I thought that it was a mistake when I got there because everybody at the pre-party was either part of Y Combinator or one of Paul Graham's friends. I found out later I was basically invited because I was one of the few people there who was older than 30, basically. But yeah, so I ended up meeting the guys there. We hung out, and then we had lunch shortly, on the last day of that startup school. And I handed them my resume, and I'm like, hey, I really want to work for you guys. And they took it, and they were like, we don't know what to do with this. Like, we've never hired anybody before. And so we ended up just chatting, being friends. They came out to California a few times, and I put them up in my apartment. And then eventually they got acquired by Condé Nast and was able to hire me full-time.
How long after Reddit started did this happen?
Well, I met them just a few months after it started. I ended up working for them in March of 2007, which was about a year and a half after they started.
I see. So that's why you were the first paid employee there. Okay.
Yeah,
that makes sense.
Yeah. Everyone else was basically a founder or sort of a co-founder.
Okay. Let's dive right in. And can you give us a general overview of what the Reddit architecture looks like?
So I can tell you what it looked like when I was there, when it started. So it was basically it's Python, and the app servers are Python, and everything hits the Python directly through an HA proxy load balancer. So the request comes in, hits HA proxy, gets farmed out to the Python app. The databases are all Postgres, and then there's also a set of Cassandra cluster and a Memcache cluster. So depending on what data you're looking for, you're either going to hit, one of those three. And then, of course, the cache will be filled up. So that's the basic architecture of Reddit.
Do you know if that has changed a good bit, or have you kept in touch with that?
From what I understand, actually, I was just talking to them yesterday, and they basically have the same architecture now. They've made, a bunch of improvements to the code, and there's stuff in there now like Zookeeper to help keep track of some stuff. But for the most part, it's basically the same concepts.
So I want to break those down a little bit more in just a little bit. But first, can you tell us some of the technical challenges that you ran into that just took down the site you were not expecting at all? What were some of those?
So basically the way we scaled the site was we would go until we hit a scaling point, and there would be a failure. Some of the failures just had to do with the way that we were doing caching. We had bottlenecks there. One of the things that we had to solve eventually was rendering. So we used Markdown, and we were using a Python Markdown library, and it was just too slow to keep up. So we ended up actually getting first we found a C library that we made into a Python module, and then there was somebody actually created one called Discount, which is what we were using, and I think they might still be using today, but I'm not sure. You could actually check in the open source code. But basically that was how we dealt with some of the scaling issues. So Markdown and was put into a C library, as was database access and memcache access were all done via C libraries. So those were some of the challenges there. One of the other big challenges we had was when we moved from a data center to the cloud, the latency between servers went from 1/10 of a millisecond to a millisecond, which doesn't sound like a lot, but when you have architected your software to make thousands of memcache calls per page load, that delay adds up. So we had to quickly re-architect to start using, more larger batches of data and things like that.
Now, this was a few years ago. Do you remember what year you switched from that physical data center to the cloud?
Yeah, that was in May of 2009.
2009. Okay, so a few years back. Would you say that you still have some of those latency issues to this day, or has it improved?
There's always going to be a little bit of latency in a virtualized environment versus bare metal. But at this point, it's been architected around. So it's a known quantity, and so you just architect around it.
And it's funny, you just said that with the Reddit, at least at first, the mentality was, we'll scale when we start hitting bottlenecks. And from what I understand and from the research I've done, that's a very different mentality from at Netflix, where you're trying to figure out what the bottlenecks are going to be before they happen. So that's going to be interesting to see the difference between that. Do you think that's an accurate comparison to make?
Yeah. Yes, so Netflix, we definitely invested a lot more in testing, particularly around that kind of testing. At Reddit, it was more a function of we only had a staff of 5-6 engineers, and so we just didn't have a lot of time to do squeeze testing. Usually the bottlenecks were found by the users before we ever got around to finding them ourselves.
Sure.
We did find some ourselves. Like we would definitely use Python profiling extensively, which helped us find a lot of bottlenecks before they became problems.
So at that size of a company with that few employees, would you say that it's more important to focus on the features first and go with that approach of, when you hit the bottleneck, go ahead and fix it? Or should you think about the bottlenecks first and think about scale from the get-go? What do you think about that?
So I would say the smart person at least puts some thought into scaling, but doesn't prematurely optimize. Good software written well will at least handle a lot of the scaling issues sort of by nature. So there's something to be said for starting off with a good architecture. But that's really more of a business decision. But in my mind, it's better to move forward on the features than the scaling. But you do have to find the balance, because if your scaling is so terrible that your site is always down, then people just aren't going to use your product anyway.
Right.
So you definitely need to find the balance between, when to focus on which thing.
So you talked about profiling, and that goes in with monitoring and that sort of thing. So let's say, for example, we have somebody listening that has a very similar website to Reddit, and they do have a small team like that. What should they be focusing on monitoring? What kind of things would you say?
So my general advice with monitoring is to monitor application metrics. You can monitor server stuff and all that, but those aren't going to be as useful to you, especially if you're in the cloud, because you can just delete those instances. So generally the things to monitor are the application metrics that matter to your business. Now, finding what matters to your business, is important. At Reddit, at least when I was there, what mattered was page views. So our main metric was page views per second.
Okay.
At Netflix, the main metric is play starts, how often someone successfully starts playing a movie. And so that was like the number one metric that was watched, was the starts per second. And those were good leading indicators, or sometimes trailing, unfortunately, of a problem, where, if that number dips down suddenly, then that something is wrong. Because normally it's very smooth. It's a very smooth curve. And so that was kind of how monitoring happened, right? Is you look at those high level application metrics, because at the end of the day, it doesn't matter if your server is, spiking its CPU all the time if it's still serving customer traffic.
Right.
So it's really more about the customer experience.
Can you remember a time when there was a dip in page views per second, and how did you debug that? How did you fix that problem?
So it happened a lot.
Right.
And debugging usually involved first checking to see if something had just been deployed,
Right.
then running to the logs to see if there was anything obvious in the logs. Eventually, we actually built a system that would fingerprint Python error messages, and so it would tell us anytime there was a new one, and it would give us the counts of every type of error message that we
Oh,
saw.
okay.
And so you could check those to see if a certain type of error had suddenly gone up. Uh, Otherwise, you would look at, we would have the monitoring that would show every server, and so you could quickly scan through that and see if any of them had, spiked CPU or had disappeared or something like
I
that.
see.
But I mean, typically the answer was in the Python logs. Maybe about half the time. About half the time, the answer was, "Oh, this server is under severe load."
Okay.
Another thing that we actually monitored a lot was queue length. So everything that could go into a queue, we try to put into a queue. So like incoming votes, incoming comments, things like that, they're all in queues. And so monitoring the queue length worked out really well, because then we could, that was a good indicator that there was a problem. If the votes queue had backed up, we knew that there was probably a problem with the vote database, for example.
What queue did you use?
We were using RabbitMQ.
RabbitMQ. Okay. And you were using Postgres for the database, right?
Yeah.
And Reddit is pretty well known for using key value storage for part of its data storage. Can you walk us through the process of why you decided to go that route? Because it seems to me like Reddit has a lot of relational data, like users' votes, users' comments, users' posts, things like that. So what was the decision behind choosing to go with key value, especially with Postgres?
So I don't really know why Steve chose that, but it turned out to be a great choice. It turned out to be great for scaling because it let us, scale the databases independently, which was really nice. So there was, when I left, we had like 19 common databases and only 2 user databases, and we had 2 vote databases, but we really only needed 1. So it just depended. The data is relational in the sense it's not relational in a typical sense of relational. There are a lot of relationships, and if you look at the database structure, there are tables that are dedicated specifically to keeping track of relationships, but those are all totally storable in key value store, right? So your key is one thing and the other thing, and then the relationship between them. So it's actually storing that kind of relationship data is actually very conducive to a key value store.
I see. So if you could go back in...
But yeah, we were using Postgres as basically a key value store.
So if you could go back in time, you'd still choose to do that?
Oh yeah, for sure.
And why Postgres instead of something like MongoDB, for example?
Well, 1, because Mongo didn't exist at the time. But 2, because Postgres is just a really good, solid database. It has 25 years of practical use. It's the cleanest code you'll ever look at. It's super solid, and it's more performant than most of those other databases. Even when it's not doing relational work, even when it's being used as a key value store, it's still more performant than most dedicated key value stores.
So would you still use Postgres to this day, even though there are alternatives now?
I would, because a lot of the alternatives are either not battle tested, hard to maintain, or have some other negative against them. So even though Postgres isn't designed for key value, it works really well that way.
I've seen a lot of debate between people concerning MongoDB recently. A lot of problems with security issues and how long it takes to fix those, and just
So MongoDB is a very special case. It's one that I would never use, only because their developers have the first few versions of Mongo all had this problem where they put speed over durability. So the write would be marked as completed even though it hadn't actually finished writing to disk yet, for example. So you could lose it even after it told your app, hey, this write successfully completed. They've fixed that since, from what I've heard, but nonetheless, their attitude was speed over durability. And for a database, I really prefer durability over speed.
Is there an alternative that you could share with us?
For Mongo? Yeah. Postgres is actually a really good
alternative. You still go with, yeah. Sure. Oh, by the way, what kind of tools do you recommend for monitoring?
So that's a really good question. It depends. If you are trying to run in like a cloud distributed environment, you really need a good distributed monitoring system, and there aren't a lot of good ones out there right now. there's Netflix has actually open sourced their monitoring system, Atlas, which is designed from the ground up to be great for use in the cloud. You could try that. There's a company called SignalFX that makes a commercial version that's very similar to Atlas. Okay. But like I know that the Reddit guys, for example, are using Graphite. I've seen Graphite a lot. Graphite is pretty nice.
Yeah.
When I was at Reddit, we were using Ganglia, which is great for monitoring large groups of machines, but not so great for a cloud environment where they're coming in and out of service all the time.
Okay. So just to be clear, did you leave Netflix and you're now full-time in Cloud Native? Is that right?
Yeah. So I left Netflix back in February, and I co-founded Cloud Native about a month ago.
Okay, I see.
Well, Cloud Native already exists, and I joined as a co-founder.
Oh, I see. Okay. Yeah, I definitely want to talk about that in a little bit. So when you have a big database like Reddit has, how do you back that up without causing downtime?
So that was not easy. So the backup strategy at Reddit is every database has at least one read slave.
Okay.
And so the backups come from the read slaves. They're dumped, PG dump off the read slave during low traffic periods. So that worked really well when I was there because there was a very distinct low traffic period. As they get more and more global, it's going to be harder and harder to do that. It basically just means they'll need more read slaves so that they can handle the losing one of them for backup.
And how much of that data could you actually cache?
So the beauty of Reddit is that it's we were cheating basically. The hot set is extremely hot. Basically everything that's on the front page today or yesterday is what's in the cache, because that's what 99.9% of the people are looking at. So it was actually caching. It was a fairly easy thing to do because there isn't really a long tail.
I see.
And you can see that when you try to load up an old page that it'll take a while to load because none of it's in the cache.
I'll have to try that out, actually. I'm not sure if I'm sure I've done that before, but never really looked for it. I thought maybe it was my internet or something. I'll have to go back and actually look for it.
Don't do that too much, though, because then you're just going to slow everything down because it's going to hurt the databases.
Sure. And
in fact, that was one of the scaling issues we had to deal with because Googlebot would come through and scrape all of the really old stuff. And so we had to rate limit Googlebot. And I think what they've now done is actually created they'll lock a page after 6 months or something. And so then that loads much faster because it doesn't have to re-render everything.
Why did you guys end up using Cassandra?
Why? So we were using this product called MemcacheDB, which was basically Berkeley DB behind Memcache, using the Memcache protocol.
Okay.
And that was working really well until it just stopped working really well. And there was no easy way to scale that. The only way to scale it was to double the size of your cluster and have a lot of duplicate data. So that sort of was the motivator for us to look into a more scalable distributed key value store.
I see.
And that's how we got into Cassandra. Looking back, we probably got into Cassandra a little early. We got in at version 0.4 or so. So, that was probably a little early. It was kind of a pain to admin at that early stage, but it worked out because it was essentially at first just used as a cache. Now I think it actually has data that's, unique data. But at the time we started using it, none of it was unique. We could regenerate everything in Cassandra. It would take a long time to do it all, but we could theoretically regenerate everything that was in there.
I see. And I've read that it has really fast negative lookup. So do you know if they still use that to look up voting?
Also, that was one of the big improvements that helped, is by having all of the votes in Cassandra. So when you load a comments page on Reddit, there's 1,000 comments there, and we need to know, how have you voted on every one of those comments? Chances are, especially if it's new to you, you've never voted on any of that. So it's very nice to be able to go in and get very fast negative lookups on those 1,000 items. We actually put in a second hack where we would record in the user database the last time you interacted with Reddit, if they voted, commented, whatever. And so if you load up a comment page that's newer than the last time you interacted, we wouldn't even have to go to the database at all because we know you could not possibly have voted on any of that stuff. So that was actually a pretty big, that was a good scalability hack right there, was sort of keeping track of the last time you interacted with the site at all let us shortcut a lot of database lookups
I was
and cache
I
lookups.
was actually wondering how you did votes like that. It seems like it could turn into a very complex and very resource intensive process if you don't do it right. So that's pretty interesting.
Yeah. Yeah, so there was that, and then the fast negative lookups help a lot
Hmm.
because since it does that because it has a Bloom filter on there, so it never actually has to hit the database.
Okay.
It doesn't have to pull in the data. It could just say there's definitely no data here.
So what other kind of data did you use Cassandra for?
Uh, what else was put in Cassandra? So Cassandra, one of the big things that it had was like caches of listings.
Okay.
So we would render, say, the listing page for our programming,
Hmm.
and store, what are the 20, it would actually store 1,000 links.
I
So it would
see.
say, what are the top 1,000 items that we just picked out? And it would store that entire list of 1,000 items in Cassandra.
Hmm.
And then essentially there was a queue. Every time a vote came in for programming, we would recalculate the 1,000 links for programming.
Okay.
Now, of course, that calculation took longer than the speed which the votes came in. So what would end up happening is a bunch of votes would come in, and it would get recalculated, and then anything that came in the interim would just get thrown away because we'd already sort of accounted for that. So that's how we kept up with recalculating. And then when you actually load our programming, what you're getting is that item, that 1,000 item cache.
Hmm. Now here's a question from the community. I actually reached out to Reddit this time and asked them what they wanted me to ask you. So here's a question from user FUKITOL dash, and the question is, what techniques were employed in future-proofing the architecture to ensure scalability as usage increases?
So I assume they're talking about Reddit.
Yes. Mhm.
At Reddit, so I don't know if we put a lot of like distinct thought into future proofing. What we put thought into was how do we make this scale as far as possible. And so using the key value store was one way to do that. Trying to do, a very, it wasn't called 12-factor app at the time, but kind of following some of those practices, shared nothing. Each app server was independent. There wasn't any state saved in the app server, for example.
Okay.
Which actually ended up being a scaling problem as well, because then you have to make sure that your cache can handle, your whatever third place you're saving all your state needs to be robust enough to handle it. But I mean, that was the big one, is the shared nothing. Every app server at least is easily replaceable. All of them are equally good. So that was one way to do it. We basically made it so that we could just bring up more app servers and horizontally scale that portion. The database is not quite as easy to scale up, but making it having support for read slaves helped a lot, because then as the load got higher, we could bootstrap a new read slave to alleviate a lot of the load. One thing we ended up doing after a while was making the master database only for writes. So you could only write data to it; it would never be read from.
Right.
That actually helped a lot, because then the local caching, memory caching on the database was more tuned to, either read loads or write loads.
Hmm. Now, Reddit and Netflix both have open sourced some of its tools. When do you think it makes sense for an app like that to open source?
That is an interesting business decision. So at both Netflix and at Reddit, what we realized, different stories, but at Reddit, the story was, we know that the value is in the community, not in the software. And so we wanted the community to be able to see the software, one, so that they could potentially help out, and two, because a lot of people had questions about how it worked. And so we wanted to show them by being like, here's the code, now you can see how it works. And also because we wanted to give back to the community, because we were using so much open source that it just made sense for us to open source. Because a lot of people would ask us, like, oh, hey, you're the biggest website running tool XYZ, how do you do it? And so by open sourcing, we could be like, oh, here's an example of how to do it. Like for a while, I think we were the biggest site on pylons. And so people would want to see sort of examples of how to run high-scale pylons, things like that. So that was the motivation there. At Netflix, it was more of a, hey, this stuff, the general rule in Netflix is if it has to do with programming or computers, it's open source, and if it's movies, then it's not. So because we know that the value in Netflix is in, the curation and the content and things like that. And so we knew that sharing how we did, it was kind of the same story though, right? We wanted to share how to run these things at high scale.
And that's extremely helpful. Like the Simian Army, for example, and Atlas, all those tools are extremely, extremely helpful. So by giving back to the community, you help out a lot of people. So that's fantastic.
That was the idea, yeah.